temperature volume relationship. Okay, what is called? This is known as Charles. Okay, what we do here? Here, for a given amount of gas at constant temperature, sorry, at constant pressure. At constant pressure, the volume of the gas increases or decreases by 273rd part of the original volume for every degree rise and fall in temperature from 0 degree Celsius. This is the original rule. That is, if V0 is the volume of gas at 0 degrees Celsius under constant, so I cannot write let pressure. Then see here, V 1 degree Celsius. From 0 to we have come to 1 degree. So it will be, new volume will be V0 plus 273 V0. This is the increase which has taken place. Then say it is V 2 degrees Celsius. So it will be V0 plus 2 into 273 V0. Similarly, V 3 degree is V0 3 into 273 V0. This is for increase. Okay. Then suppose we lower the temperature, it will decrease. So it will be V minus 1 degree Celsius. So it will be V0 minus 1,273 V0. Then minus 2 degrees Celsius, V0 minus 2 into 273 V0. So we can go like this. Okay. Now a time will come, it will be V minus 273. So it will be what? V0, then 273 into 273 into V0. We'll come across this. So what will happen in that case? In that case, you'll find the total volume will be what? 0. This is absurd. It is not possible. Volume of any substance cannot be 0. Why? Because we know law of conservation of mass. The substance cannot be destroyed. Neither we can create or nor we can destroy it. So it is not possible. But anyway, this experiment is not wrong. Because these are all experimental results. So there is something else is there. All right. Now, this much temperature you cannot reach. But how did they do it? They have done the experiment and they have plotted it in a graph because so much of temperature, and in those days it is not possible. So this is the graph. All right. This is the volume axis and this is the temperature axis. So this is 0 degrees Celsius. Okay. This side is positive and this side is negative. So they have done few experiments and they have plotted in the graph and they got this line like this. So these are the experiments he has done. 1 degree, 2 degree, 3 degree, 4 degree, 5 degree. Okay. So it is 1, 2, 3, 4 like this. So similarly here, say it is minus 1, then minus 2 like this. So after plotting with the help of a scale, this is called extrapolation. This is helpful. When they extrapolated, they got a value 273.15 degree. Okay, so this is here where you find the volume ceases to exist. So 273.15, this is the exact values. We always say minus 273, but actually the actual value is minus 273.5. So this is being called absolute zero. This is called absolute. All right. Okay, right. So in this case, have you finished writing?
Yes, sir.
Okay, now what did you find here? When the volume increases, when the temperature increases, volume increases. And when the temperature decreases, volume decreases. All right. So from there, Charles have given a simple explanation. So he has mentioned that for a given mass of gas at constant pressure, the volume of the gas is directly proportional to the temperature. That is, V is proportional to T. Or you can write T is proportional to V. Or you can write T is equal to K into V. So you can write here 1, where K is the proportionality constant. Okay. Or you can write like this: V1 by T1 equal to V2 by T2 equal to V3 by T3, and dot like this equal to constant. Therefore, V1 by T1 is equal to V2 by T2. Therefore, V1 by V2 is equal to T1 by T2. This is called Charles law. Done.
Yes, sir.
Okay. Then now we'll go for third. It is temperature pressure relationship. Okay, so this is called Gay-Lussac's law. For a given amount of gas at constant volume, the temperature is directly proportional to the pressure. This you can say T is proportional to P, or you can say T is equal to K into P, where K is the proportionality constant. So therefore you can write T by P is equal to K, or we can write T1 P1 equal to T2 P2. The fourth, this is the third one. Huh? What's the first? Starts the second. Is right condition third. Now we'll go for fourth. So here we'll write relationship between volume of the gas and amount of the gas. This is obvious only. So this is known as Avogadro's law. So what does it say? Equal volume of all gases under similar conditions of temperature and pressure contains same number of. So what does it say now? V is proportional to N. So these are the four gas laws.
Finish, sir.
Okay. Now, what we'll do, we'll write down all the gas laws together. So, what are the gas laws you have seen? Gas laws. See here. One. We find that according to Boyle's law, what do you find? That B is proportional to P. So I'll write the equation 1. Then Charles' law, we find that B is proportional to T. Equation 2. Then third, Avogadro's law. You find V is proportional to N. Okay? And the fourth one, Gay-Lussac's law. We find that P is proportional to T. So in this first three, we find volume is common.
Excuse me, sir.
Yes.
Isn't it Boyle's law V is inversely proportional to P?
Oh. So, correct. Thank you. Okay. So now what we can write? Combining equations 1, 2, and 3, we can write that V is proportional to N, T, and P. Or we can write V is proportional to R, N, T by. Okay. So right now we have equation 5, where R is a proportionality constant. Therefore, you can write P V equal to N R. All right. So I'll write here now 6. Not 6, 5 only. Say only. This equation is called equation of state. See, I'll tell you this is called ideal gas equation, but till we do not know it is called ideal, so I have not used this till now.
Finish, sir.
Okay. So now we can write this equation further like this. So this equation I can write like this also. PV is equal to nRT, or I can write PV by T equal to nR. Why did I write? Because these two are constant. Amount of the gas that you have taken, this is constant, and R is a constant. So similarly, I can write down here P1 V1 by P1 equal to P2 V2 by T2, P3 V3 by T3. Okay, all be equal to what? N R. Therefore, I can write P1 V1 by T1 equal to P2 V2 by T. Okay. So this one I get me writing here 6. This equation is called combined gas law. এটা হই কইলে we'll go to another law now. It's called Dalton's law of partial pressure. What is the meaning of partial pressure? Part of the total pressure. Say you want to open a door. Okay. So it is being somehow it being got jammed and you could not open it. All right. So when you tried, you could not open it. So you have taken the help of a friend, or suppose a big boulder is there. A very big boulder is there, and you want to remove this one. So when you tried, you failed. Then you take the help of your friend. So many of your friends has lended their hands, and somehow the stone is being removed. So what is the pressure of the force that you have applied? The total pressure is equal to the pressure of X, Y, and Z. So these pressures are called partial pressure. Part of the total pressure is called partial pressure. Okay. So when you have taken a mixture of gas, take the example of air. When you say atmospheric pressure is consisted of the pressure because of the different gases which are present in air. Nitrogen is there, oxygen is there, carbon dioxide is there, water vapor is there. So this atmospheric pressure consists of the sum of the pressure exerted by all the gaseous components present there. It may be large, or it may be small, or it may be minute. All right. So this is called the partial pressure. These are very simple thing but that is being done around 200 years back. So that was a very big thing those days. So the total pressure exerted by the mixture of non-reactive gases is equal to the sum of partial pressures of all individual gases. Okay, say this is a balloon or a container. Okay, but you should know also how to measure the pressure. See, for pressure we are using barometer, or you can also use a meter. So this is this instrument. So this is, we call this to be manometer. So this is the total pressure. I'll write now here. P total. All right. So here you have gas A, B, and C. So what is the total pressure now here? Right now, let a container has A, B, and C gases having partial pressures of PA, PB, and PC. Therefore, total pressure. So I'll write now here P total is. So what will write now here? P total. Yeah. For partial pressure, we always write small p, not the capital one. So I'll write now here PA, PB, and PC. So that is this mathematical expression of the Dalton's law of partial pressure. So let me write now here. Using gas laws, gas equation. Or in that PA equal to, see, we know PV is equal to nRT. So I can write what? P is equal to N by V RT. I can write or not? Huh? So I can write down here. See, gas, it is Na moles V RT. Okay. Again, I'll draw this container. See here. Is A, B, and C gases are there. What is the V here? See, for all of them, for all the gases, volume is same, V. Because we did not take in other container, only one container. Okay. So now we can write here PB is equal to NB. This is the number of moles of B, number of moles of A. Huh? If moment you don't understand, tell me. Don't keep quiet. Hello, Miss Sharon. Huh? Miss Sharon Lapang, she is there.
Yes, sir.
हाँ, कुछ भी नहीं समझा तो हमको बोलो.
Okay, sir.
PC is equal to NC. So please do not hesitate to ask me. See here. Why did I write same T? Because the temperature of the container is same. Volume of the container is also same. Okay. Now, all right. So let me write down here. We know that P total is equal to, we have got for Dalton's law of partial pressure is equal to this. Just now we have written. So let me add now here. It is NA, NA subscript. Huh? NB RT, then NB V RT, NC V RT. See now this they are common. So can I not take this common? So I can write here NA plus NB plus NC RT by. Okay, right. By the end of this month, I'll try to send you. Because I'm not getting so much time to write also. So this physical chemistry portion, I'll send you note. My original note is very big. So in that case, 1, equation 2, equation 3, then this is equation 4. All right. Ratio. The ratio between the partial pressure of any gas and the total pressure of the gaseous mixture. So I can let me take anyone, So I'll write now here. So it is PA by P total. So let me write here. What is PA dear? We know it is NA RT by V. And what is this? It is NA plus NB plus NC RT by V. Now, see, can I not cancel this one? So what do I get? That is PA by P total equal to NA plus NB plus NC. Dear, try to remember, recollect your first chapter. What is this? This is capital. This is small. This is we call. This is the mole fraction. So it's equal to mole fraction of A. See, this is the another definition that I'm going to write now. This is another definition of Dalton's law of partial pressure. Okay. So, therefore, what I can write? Therefore, I can write PA is equal to chi A P total. I can write thus partial pressure of any gas in a gaseous mixture is the product of total pressure of the gas. I'll write here now. P total. And its mole fraction. I'll write here chi. So if I go for PB, it will be chi B. If I go for C, PC, then it will be chi C. So this is the another definition of Dalton's law of partial pressure. See, from this chapter, you have to do numerical. Okay. Then we'll go for kinetic. Molecular theory of gases. What is the meaning of this? Because we know in gaseous state, molecules are constantly moving. Okay. In solid only you'll find as the substances are very, very close to each other, they do not have any space to move. So in solid state only the molecules remain in one place. In case of liquid, the molecules move because they have some space, but that is not as large as gaseous substances. So if this is a box containing gaseous molecules, you'll find the gas molecules constantly they move. Without any rest, constantly they move within the within the container. This is the one that we are going to explain. See here, the gas molecules are so small if you compare with the volume of the container. Okay, they are very small. And they have a large distance between or among them. Just a minute. The gap between them is very large. And so it is assumed that volume occupied by the gas molecules, if you compare with this, it is negligible. Okay? The volume occupied by the gas is negligible. See, you can understand how far the gas molecules remain away from each other. See, we can walk through the air. Not only we, big vehicles also can move through the other. So what does it mean? If the space is not there between them, we will not be able to move. So the gas molecules are very, very far away placed from each other. So we always consider the gas molecules have negligible volume. All right, and we consider the gas molecule as point masses. Try to understand the word point masses. Means every gas molecules have their own mass. Mass you cannot forego. And as their volume is less, So I can consider that this gas molecule is like this. So this is called, but this is having a mass. Because of that, we consider the gas molecules are having point masses. And gas molecules, they continuously they move, randomly they move. Ceaseless motion is there. All right. But whenever they move there, they always move in straight line. Okay? They always move in straight line. They can change their direction only when it comes and hit this one, and then direction might change. Or when they hit the wall. When they hit the wall, okay, then you'll find the gas molecules will again move here, and you can again move here. The best example, I think, you in your houses, if you have a computer screen, you'll find there at some time this type of movement is being they've shown you. This is called the kinetic movement. So the gas molecules undergo continuous movement. They always move in straight lines. They change their direction only when they collide with other gas molecules or they collide with the wall of the container. Others, they are not going to change. Clear? Huh? And we find their velocity or the kinetic energy of gas molecules is going to change only when the temperature changes. That is, we can say the kinetic energy of the gas molecule is directly proportional to the temperature of the gas. So I'm going to write some some postulates or our observation about the or our assumption about the gas molecules. Okay, we'll write now. Postulates of kinetic. See, in your book, they may write kinetic molecular theory, but most of the book they write kinetic theory. Okay. So if you wish to write like this, I will put inside bracket. So don't get confused. If in exam they write, don't write kinetic molecular theory, then you don't get confused. You may write kinetic theory of questions. Okay. Because most of you by heart na. So when you by heart it without understanding, little change in the word can lead to confusion. Actual theory name is kinetic molecular theory of gases. So right now one. Gases consist of large number of identical particles. Please excuse me for using the word particles. Why you know? Because some gases exist in the form of atoms, some exist in the form of molecules. Now you know which are the gases exist in atoms. These are the noble gases, atoms or molecules. Gases like hydrogen, oxygen, nitrogen, they exist in the form of molecules, but in the form of noble gases, they all exist in the form of atoms. These are so small and have large gap between them. Okay. They are so small, that's a comma, have large gap between them. And remain far away from each other. Right now, comparing the volume of the container. They occupy small volume. And so considered as point masses. Explains the volume of the gas molecules. Okay. Second, the molecules are in a state of ceaseless, means without stopping motion. In all directions. During the collision, sorry. During the motion, they keep on colliding with one another and the wall of the container. And thus change their directions. I know that much, huh? So, and I'm trying to write it the easiest possible language. Okay. Five. See, when they collide with each other, total energy of the gas molecule does not change. All right. So this type of collisions are called elastic collisions. See, elastic, you have seen If you pull it, leave it again, it comes to the same position. So you write molecular collisions. Molecular collisions are perfectly elastic in nature. What is the meaning of this? That is, no loss of energy. No loss of energy takes place. However, there may be redistribution of energy. See, total energy remains same. Maybe that molecule A may give little more energy to B. So in that case, the velocity of B may increase. But if you add the energy of A and B, it is total. It's totally same. There are no forces of attraction. These molecules, they don't attract each other. Between the gas molecules. Between the gas molecules. That is, it's just like that you are crowd walking in a crowd. You know none of them. In this process, what may happen? Suppose you go and collide or hit with the other. Maybe the person in front of you has pushed it little far. Okay, but you did not collide. You do not hurt him intentionally. At ordinary. What is the ordinary conditions? Means normal conditions of temperature and pressure. Fine. The average kinetic energy of the gas molecules is directly proportional to the absolute temperature. Okay. What is the meaning of this, dear? Kinetic energy is directly proportional to T, or you can say half mv square is proportional to T. M is the mass of the molecule, V is the velocity of the molecule. Okay. In book, it is not being given. In exam also, you don't write. Just to make you understand, I have written. This kinetic postulates of kinetic gas equation is extremely important for class 11 students for exam. Okay, please read it. If you wish, you can change some words which is convenient for you, but please remember it is going to come in the exam. See, in earlier syllabus, you were supposed to go for the derivation of this kinetic gas equation. But anyway, for last 3 years, this derivation is being removed. So anyway, I think you should thank them, but I'm little sad. Okay. So I'll write now here. From the above postulates an equation is derived. And is known as kinetic gas equation. What is this equation? PV is equal to 1/3 m n c square. Okay, actually, if I write, I'm a little conservative. We write like this, c square. So what is P now? Where P is equal to pressure of the gas, V is equal to volume of the gas. Okay. What is M dear? Mass of individual gas molecule. What is N? Total number of gas molecule. What is this C square? Is called average square velocity of gas